power factor test layout. We have an arrangement here where we have a supply source 230 volt, and we have an inductor and a lamp, and there are two resistors. They all are connected in series. This being an inductor is a tube light choke, iron choke which you have taken, and we have taken a lamp also in series, and then we have taken two low value resistors for measuring the current, and these are the capacitors which are in fact meant for improving the power factor, while these relay contacts they get switched on automatically based on the power factor. We also got a CT, a current transformer, and this has a provision with a single pole double throw switch, SPDT switch, meaning that when this switch is at this side, this CT is connected between this and this, so it will measure the current here. And when it is thrown to this side, this will measure current between here to here. What is the difference between this current and this current? Now all we know that prior to compensation of these capacitors coming into circuit, the current flows this way, this way, this way, this way, and this way. So what happens if there is a choke here, so it's an inductor, so the current will lag behind the voltage. That means this current and this current both will be same, and this is a lagging current. So what the arrangement would be that we would connect the switch SPDT switch to this position, so that when the current flows, the CT is connected between this and this point, and the voltage picked up, whatever is the voltage drop here, is picked up by this CT, and it is developing a correspondingly higher voltage here, and this voltage goes to current sense circuit. And when this switch switches to this side, for example this side, now this and this point, the CT gets connected between this and this point to measure this current. But in a situation where the capacitors are not connected, this current and this current are all same. After we read the current, the inductive current, which will be sensed by the CT and when given to the control circuit, the capacitors will come into picture automatically. Now once the capacitor come into picture, the current between this zone and current between this current will be same, but because the capacitor from here to here the current will be different, and from here to here the current will be different, because once they are compensated, like for example if they are compensated like this, if suppose one capacitor is switched on, one capacitor is switched on, that means we will have compensated current here, but this will still continue to be having a lagging current. So this is the arrangement which has been made to see both the lagging current and the compensated current. So, and if you want to see the linear load, we bypass the inductor. There is a switch here, we bypass the inductor, so the current flows bypassing the inductor directly to the lamp, and we know the lamp is a linear load and the power factor would show us very close to 1. That will be sensed by this and will be given accordingly. In a linear load, when whether we keep the switch to this side or to this side, the reading will be same. However, if an inductor is used, that means when the switch is open, the inductor and the lamp both come in series, so inductance dominates, and because the value of R is very high, uh, the value of R will be very low, so in the process the inductor will be dominating, and that inductance dominating means the current will be lagging, and that lagging current will be sensed while the switch is this side and will be given to the control circuit. And we know in the control circuit we have a voltage sense arrangement already existing, and this current which is lagging or in line will be fed to the control circuit to give us the reading. One precaution has to be taken only, that this switch should be always kept in this position because the inductive current is flowing through this. But the moment we keep it to this side, this will measure the corrected current. And since the sensing circuit is given from here, once it measures the corrected current, it will immediately correct the capacitor also. That means capacitors will open. And again it finds that the current is lagging, so capacitors will close. In the process, capacitors will close, open if we keep it permanently to this side. That is how we have to keep the switch this side always, so that only in the event of seeing how much compensation has been done and what power factor has come, we have to bring it to this side and then again bring it back to this side so that it still gets the inductive current. There has been a time lag provided for this, so we have to come back from this position to this position immediately within about a couple of seconds after reading the power factor. So this is what has been the arrangement for the control board. Apart from the control board, the layout board. However, these capacitors may be placed in the control board or it can be separately placed, but this is the basic concept. Thank you.